Have you ever examined whether we're really alone in the universe? Then again, assuming there's something more to our reality other than anything we see, imagine what is happening. Consider the possibility that the James Webb Telescope finally shows that we live inside a black hole. Join us as we explore more about this world, getting the message out that will make you question everything you thought you knew about the universe. So, what precisely are black holes? They're like something out of a thrill ride. Sure, you could have seen them in science fiction films, but what's even more upsetting is that they're not just a made-up idea. According to well-educated specialists, black holes in space are truly colossal amounts of matter compacted into an unthinkably small region. Imagine a star a few times more massive than the Sun, all pressed into a space the size of New York City. The gravitational pull is so extreme that nothing, not even light, can escape from it. Researchers have been fascinated by black holes for quite some time. Initially, they thought about objects in space so massive and dense that they could trap light. The most striking ideas about black holes were proposed by Einstein's theory of general relativity. Essentially, when a massive star dies, it leaves behind a dense core. If this core's mass is a few times that of the Sun, gravity overpowers everything else, leading to the formation of a black hole. Detecting black holes is no simple task, since they emit no light. However, scientists have found ways to interpret their presence by observing their effects on surrounding matter. For instance, if a black hole passes through a cloud of interstellar matter, it will pull matter toward it in a process called accretion. Furthermore, when a normal star gets too close to a black hole, it can be destroyed, emitting X-rays as it does so. Black holes also have a significant impact on their environment. They can consume nearby stars, produce strong radiation, and even affect the formation of new stars in certain regions, while suppressing it in others. So, how do black holes come about? Picture this. Stars, once bright and shining, meet their blazing end in a massive explosion called a supernova. From the remnants of these fallen giants, black holes arise. Most black holes form from massive stars that have reached the end of their life cycle in a supernova. However, smaller stars, when they die, turn into something many refer to as neutron stars, which are incredibly dense, but not dense enough to trap light. However, if a star is a few times the mass of our Sun, it falls under its own gravitational force, forming a black hole. As these massive stars collapse, something unusual happens near their surfaces. Time itself begins to play tricks. From the perspective of someone far away, time seems to slow down near the event horizon, the defining point for anything falling into a black hole. The clock ticks at a different speed compared to hours elsewhere. Occasionally, when two smaller black holes collide, they merge to form a much larger and more frightening black hole. If a black hole interacts with a neutron star, it creates a cosmic nightmare that defies comprehension. Scientists have been grappling with the size of these vast phenomena for a long time. Black holes come in two sizes, massive and small. There's a bit of a misunderstanding about them, though small is relative when it comes to black holes. Extremely large black holes, the remnants of giant stars, can be as much as 10 million times the mass of the Sun. There could be anywhere from 10 million to a billion of them in the Milky Way alone. That's a huge number of black holes that could swallow anything in their path. But wait, there's more. Supermassive black holes exist at the outer extremes of the scale, being millions, if not billions, of times greater than the Sun. These reside at the centers of massive galaxies, including our own Milky Way. They seem like a giant empty space, pulling everything toward them. The renowned physicist Stephen Hawking talked about black holes throughout his life. His theories were well established, but some of his ideas proved difficult to confirm due to a lack of cutting-edge technology. But now there's hope on the horizon. An extraordinary instrument is changing everything. It's known as the James Webb Space Telescope JWST, and it's here to explore the depths of our universe. Let me tell you, the JWST is no ordinary telescope. It's an engineering marvel, a testament to human creativity. Sure, we've launched other space telescopes before, and they've done their job competently. But this unprecedented machine is on a level that's truly exceptional. The JWST makes the Hubble, which has served us for many years, look like a basic tool in comparison. The retail cost of this galactic marvel is an astonishing $1 billion. Yes, you heard that right, a stunning number of zeros. It took the combined efforts of NASA, the European Space Agency, and the Canadian Space Agency to bring this wonder to life, with huge contributions from over 300 universities. However, we shouldn't forget the risks that come with such a grand project. I understand this isn't an endeavor for the faint-hearted. The JWST is venturing into uncharted territory, pushing the boundaries of what we know and taking us to places we've only dreamed of. After a successful launch, NASA recently announced that the telescope has enough fuel to last several times its original mission life. Since its launch, the JWST has already achieved numerous incredible feats. It traveled over 1 million miles to reach its orbit around the Sun, where it will reside for the foreseeable future. During its journey, the telescope successfully deployed its massive 5-layer sunshield and large primary mirror, both of which had to be folded to fit into the launch vehicle. Now, after aligning and calibrating, the telescope is nearly ready for full operation. One of the most exciting moments of the James Webb Space Telescope's mission was when NASA revealed that it had captured its first significant images of starlight. The first picture taken by the telescope was of a star called HD 8446, revealing a series of 18 scattered bright spots from the star's light, collected by the 18 mirror segments arranged on the primary mirror. NASA later released another stunning image of HD 8446, in which the 18 unfocused duplicates of the star were arranged in a deliberate hexagonal pattern. Once the observatory tweaks the individual segments of the primary mirror, it will begin the process of stacking images on top of one another to form one clear view. Thanks to its advanced technology, the JWST will help scientists study the early stages of the universe following the Big Bang. It will focus on what happened after the first stars formed, a period known as the epoch of reionization. This refers to when neutral hydrogen was reionized, given an electric charge again by radiation from these first stars. This involves looking back billions of years, which is only possible with a powerful telescope like the JWST. The telescope will also assist researchers in finding exoplanets, which are notoriously difficult to detect due to their interaction with their host stars. Strong observations can now closely study these planets, allowing scientists to analyze their atmospheres and explore the conditions necessary for life. The JWST's capabilities will help scientists better predict whether specific planets could be habitable. Beyond focusing on planet formation, researchers will study these worlds to understand how matter is organized on a massive scale. This, in turn, will help us understand how the universe has evolved, shaping the galaxies we see today over billions of years. From different angles, one of the JWST's goals is to look back at the earliest galaxies to better understand how they developed. Researchers are also trying to determine how we got the variety of galaxies we see today and the ongoing processes that lead to the formation and merging of galaxies. Ultimately, the James Webb Space Telescope will help us answer the most fundamental questions of all. Are we alone in the universe? Are we living inside a black hole? The JWST has already been on the hunt, and guess what? It has found polycyclic aromatic hydrocarbons, PAHs, lurking around massive black holes in 3 active galaxies. These carbon-based molecules with ring-like structures seem to be the goth of the universe. They're found everywhere, from distant galaxies to comets in our own solar system. Now, they're not just fascinating because they could form the building blocks of life, but also because they help science track star formation. When intense radiation hits these PAHs, they become excited and emit infrared light, a signal that can be detected by the JWST's mid-infrared instrument MIRI. This is often a sign that there are some hot, energetic stars nearby. But wait for the amazing twist. A leading astrophysicist, Ismael Garcia Bernard from Oxford University, decided to explore three intriguing galaxies, NGC 6502, NGC 731, and the highly lovely Stephan Quintet, as well as NGC 749. These galaxies are millions of light years away in the depths of darkness. What Garcia Bernard found will send chills down your spine. In those central regions where the black holes reign, he noticed an abundance of PAHs. Sounds interesting, right? Well, here's where it gets creepy. The radiation near these massive black holes altered the structure of the PAHs, transforming them into larger, electrically neutral versions of themselves. The smaller, electrically charged PAHs evaporated into nothingness, consumed by the very darkness. However, the larger PAHs survived, finding refuge inside thin, dense gas clouds. Perhaps they found their own protective shelter against the fierce pull of the black holes. Now, you might ask, why does this dark twist matter? Well, for astronomers who rely on PAHs to trace star formation, it's a huge deal. Star-forming regions are often completely saturated with electrically charged PAHs, and if those particles are destroyed, it complicates our understanding of star creation. As it turns out, the survival of these larger, electrically neutral PAHs could offer key insights into how stars form and evolve in the extreme environments around black holes. The fact that these molecules can endure in such hostile conditions suggests that the building blocks of life, complex organic molecules, might be more resilient than previously thought. This discovery could also alter our understanding of how galaxies, stars, and planetary systems develop, particularly in regions near supermassive black holes. The James Webb Space Telescope's mission is truly revolutionary. It's not just a tool for observing distant stars or planets. It's a window into the deepest mysteries of the cosmos. By peering into the heart of galaxies, observing the formation of stars, and tracking the complex processes that govern the universe, the JWST is answering questions that have puzzled scientists for centuries. One of the most intriguing aspects of the JWST's findings is its ability to explore areas of space that were previously out of reach. By observing the faintest signals from the early universe, the telescope will allow scientists to test theories of cosmic inflation and the formation of the first galaxies. The information gathered could rewrite our understanding of the origins of the universe and its evolution over billions of years. Moreover, the JWST's sensitivity to infrared light makes it uniquely suited to study the birth of stars and planetary systems. It can peer through the dust clouds that often obscure our view of these processes, providing us with a clearer picture of how stars and planets form. This could have profound implications for the search for life elsewhere in the universe. By studying exoplanets in greater detail, the JWST could help us identify planets that might harbor the conditions necessary for life. The telescope's ability to detect distant worlds and analyze their atmospheres is another breakthrough. Using its powerful instruments, the JWST can identify the chemical compositions of exoplanet atmospheres, looking for signs of habitability, such as the presence of water vapor, oxygen, or methane. These are all potential indicators of life. In this way, the JWST could play a crucial role in the ongoing search for extraterrestrial life. However, the challenges that come with studying these distant worlds are immense. The vast distances between us and the farthest reaches of the universe mean that many of the objects the JWST observes are billions of light years away. This makes the task of interpreting the data incredibly complex. But thanks to the power of the JWST's instruments, scientists are now able to look further into space and back in time than ever before. The telescope is not just a tool for observing the cosmos, it's a portal to new discoveries. With each image captured and each piece of data gathered, the JWST is unlocking secrets that will shape our understanding of the universe for generations to come. Whether it's uncovering the mysteries of black holes, exploring the formation of galaxies, or searching for signs of life on distant planets, the telescope is revolutionizing space exploration. As we continue to explore the vastness of space, the questions remain: are we alone? What is the true nature of our universe? And could we be living inside a black hole ourselves? The answers to these questions may be closer than we think, thanks to the unprecedented capabilities of the James Webb Space Telescope. In the coming years, the JWST will continue to gather data, sending back groundbreaking discoveries that will redefine what we know about the cosmos. As scientists analyze these findings, we can expect even more astonishing revelations about the universe. Revelations that may challenge our deepest assumptions about space, time, and our place in the cosmos. So, while we don't yet have all the answers, one thing is certain. The journey to uncover the mysteries of the universe has only just begun, and the James Webb Space Telescope will be at the forefront of this exciting new era in space exploration.